Beyond the luminous central ring of the Ring Nebula, scientists have observed unique peaks stretching in opposite directions from the central star. These features are most prominent in the infrared spectrum, making them difficult to detect with telescopes like Hubble that rely on visible light. Experts believe these peaks could be linked to molecules that form in the colder, denser regions of the nebula, areas that are naturally shielded from the intense radiation emitted by the dying star at the center. In these shielded zones, molecules are more likely to survive and even thrive, allowing the infrared sensors of the James Webb Space Telescope to detect their presence. The telescope's powerful instruments didn't stop there. They also captured striking details of the ring's filament structure and revealed the presence of around 10 faint concentric arcs in the nebula's outermost regions. These circular features resemble the rings of a target and appear to have formed approximately 280 years ago, an unexpected finding. No known stellar process can easily explain such a regular pattern of arcs appearing over such a specific timescale. One compelling theory suggests that a hidden companion star may have played a role. Orbiting at a distance comparable to Pluto's orbit around our Sun, this secondary star might have influenced the material ejected by the dying star, shaping it into rings as it expanded into a planetary nebula. Dr. Roger Wesson of Cardiff University explained that previous telescopes simply lacked the sensitivity and spatial resolution needed to detect these faint outer arcs. The discovery adds another layer of mystery and beauty to this already iconic object. It also reinforces the value of repeated observations, as this was not the first time the James Webb Space Telescope studied the Ring Nebula. Its ongoing observations are continually reshaping our understanding of these enigmatic remnants of stellar death. The Ring Nebula's story is also a tale of human progress and curiosity. First discovered in 1779 by astronomers Antoine Darquier de Pellepoix and Charles Messier, it was added to Messier's catalogue while he was tracking a comet through the constellation Lyra. Back then, it was mistakenly classified as a planetary nebula because of its rounded appearance. In reality, planetary nebulae have nothing to do with planets. They are the final, glowing shells of gas expelled by Sun-like stars in their last stages of life. Today, the Ring Nebula has become a symbol of astronomical discovery and cosmic archaeology. Its colorful, ring-shaped structure represents the final breath of a once bright star, now evolving into a white dwarf. In studying it, scientists are not only looking at a faraway celestial object but are also unlocking insights into the life cycles of stars, past, present, and future. In fact, it's quite possible that our own Sun will one day produce a similar nebula, about 5 billion years from now. While humanity will likely not be around to witness this transformation, it remains a poignant reminder of our shared cosmic fate. The colors seen in the images of the Ring Nebula can vary dramatically depending on the telescope and the wavelengths observed. The James Webb Space Telescope operates primarily in the infrared spectrum, which is invisible to the human eye. Raw images from Webb initially appear in black and white. Image processors later convert these into visible light representations by assigning colors to different wavelengths. This process allows astronomers to highlight specific features in the nebula that would otherwise remain hidden. Thanks to its state-of-the-art infrared capabilities, the James Webb Space Telescope is revolutionizing how we view the universe. From unveiling the structure of dying stars to peering into the earliest galaxies, it offers astronomers a powerful new lens into the mysteries of space. With many more years of exploration ahead, one can only wonder what new discoveries lie in wait. Just when scientists believed the revelations from the James Webb Space Telescope had reached their peak, something even more mystifying emerged. Webb began detecting spectral signatures unlike anything seen before, light imprints without any identifiable origin. These weren't emissions from stars or galaxies. Instead, they appeared as faint, ghost-like distortions embedded in the cosmic microwave background, the ancient afterglow of the Big Bang. What startled researchers the most was their precision, patterns so deliberate that they defied any explanation grounded in random cosmic processes. Some physicists began to suspect that these might not be natural occurrences at all, but echoes, residual traces of a universe that existed before ours. This idea aligns with an intriguing and controversial theory known as conformal cyclic cosmology, proposed by renowned physicist Sir Roger Penrose. According to this view, the universe undergoes endless cycles of death and rebirth. Instead of having a singular beginning, each cosmic era ends in such complete entropy that it gives rise to a new one, preserving some fingerprints of the previous version in the process. If these ghostly imprints are indeed remnants from a previous universe, then Webb hasn't just given us a new look at our beginnings. It's offered a glimpse into a lineage of universes, a timeless chain stretching beyond our comprehension. What makes this even more unnerving is where these echoes were found. The same regions where Webb had identified ancient galaxies forming at inexplicable speeds. Could these galaxies be more than early cosmic structures? Could they be survivors? Fragments that somehow endured the end of a previous universe and seeded the next? If that's true, then the history of our cosmos isn't merely ancient. It's recursive. And possibly eternal. Then came another disturbing clue, this time unearthed with the help of artificial intelligence. When scientists used AI to overlay Webb's deep field images, those that capture the oldest and most distant parts of the cosmos, they noticed an unsettling pattern. Galaxies, billions of light-years apart, appeared to mirror each other. Their shapes, alignments, and distributions showed a kind of bilateral symmetry that shouldn't exist in a universe born from chaos. It was as though the cosmos had folded in on itself, like some higher dimensional structure shaped by a force or logic beyond our understanding. Some theorists have proposed that this mirror-like order hints at a hidden framework, a higher geometry or lattice underpinning reality. If so, the universe may not be a random collection of matter expanding into nothingness. It might be a projection from a deeper mathematical or simulated system. In this context, those mirrored galaxies are not coincidences. They are intentional patterns, embedded in the structure of space like brushstrokes in a vast, cosmic design. As Webb continues its deep survey of the cosmos, a chilling realization begins to take hold among scientists and theorists alike. We may not have been the beginning at all. The classic idea of the Big Bang as a spontaneous burst from nothing now seems increasingly simplistic. Instead, what we're seeing might be the remnants of a carefully orchestrated emergence. Galaxies like MOMS 14, with their unnatural chemical makeup and accelerated development, don't look like natural outcomes. They resemble planted seeds. If the universe was seeded, not born, it implies intent. Intelligence. A level of cosmic engineering that predated stars, planets, and even atoms. The high nitrogen levels, the unexplained symmetry, the phantom echoes. All of it points toward something that not only understood the mechanics of star and galaxy formation, but guided it. That leads to the most profound question of all. Who, or what, planted those seeds? And if something did, are they still observing their creation? Are we part of a vast experiment? Or a cosmic cycle being cultivated and studied over eons? The light reaching us now from ancient galaxies is not just illumination, it is communication. A whisper across time, telling a story of architects we never knew existed, of cycles we never knew we were part of, and of an origin that stretches far beyond a single explosion in the void. Webb hasn't merely disrupted our scientific models. It has shattered the illusion of a solitary beginning. What we once saw as randomness is now showing structure. What we assumed was natural is beginning to look deliberate. And what we thought was the entire story of existence may be only the most recent chapter in an unfathomably long saga. The stars are no longer silent. They are speaking in patterns, in echoes, and in light older than time itself. They speak of civilizations, of resets, of vast cosmic designs invisible to the naked eye but unmistakable to the instruments we've only just learned to build. Perhaps these answers were never meant to be found. Perhaps we have stumbled onto truths too vast, too intricate, too foreign for a young species still fumbling through its own history. But here we are, face to face with those truths, staring into a universe that might have been designed. Not for us, but with us in mind. The question is no longer simply where did we come from? It's deeper now. Who built the stage we stand on? Who scattered the stars with such intent? And why have we been allowed to see it now? As we continue to decode every light signature, every anomaly, and every cosmic clue, one thing becomes clear. Our place in the universe was never as random as we believed. And maybe, just maybe, discovery was always the plan.